A star system exists that physics textbooks say is impossible. This is the forbidden binary, a pair of stars that disobeys all known laws. By the end, you will understand a mystery that could force us to rewrite the rules of the cosmos. We are going to explore orbits that defy gravity, stars that should not be partners, and energy that appears from nowhere. How can our universe contain something that breaks its own fundamental rules? The first clue arrived not as a dramatic announcement, but as a stubborn anomaly in a vast digital sky survey. Astronomers sifting through data from the European Space Agency's Gaia Observatory, a mission meticulously mapping the positions and motions of over 1 billion stars, stumbled upon a catalogue entry that refused to behave. Officially, it bears the dry designation HIP, followed by a string of numbers, a name that belies its extraordinary nature. The initial data showed a pair of stars locked in an orbit so tight, so blisteringly fast that it immediately raised alarms. The calculated orbital period was mere hours, a dizzying dance that defied all conventional models of stellar evolution and gravitational physics. This was not just unusual, it was fundamentally wrong. The gravitational forces required to keep two stars from tearing each other apart at that proximity were off the charts, suggesting masses that the star's observed light simply did not support. The light signature itself was another puzzle, a blended spectrum that hinted at compositions and temperatures that should not exist side by side. In observatories and university offices, the reaction was a potent mix of profound confusion and electrifying excitement. Here was a system that, according to every established law written in their textbooks, could not possibly exist. Yet the data was clear, repeatable, and utterly impossible. The forbidden binary had announced itself not with a whisper, but with a scream of defiance against the cosmos's own rulebook. The heart of the rebellion lies in the dance itself. This stellar pair whirls around a common center of gravity with a ferocious intimacy that physics says should end in catastrophe. Think of it as two massive locomotives, each weighing many times our own sun, tethered together by a chain only a few million miles long, and then spun at a speed that would make a bullet seem slow. According to Kepler's laws of planetary motion, refined by Newton's universal law of gravitation, there is a strict and predictable relationship between how far apart two orbiting bodies are, how massive they are, and how fast they complete a lap. It is a cosmic balancing act. For any given distance, there is a specific speed required to maintain a stable orbit. Go too slow and gravity wins, pulling the objects into a fatal collision. Go too fast and centrifugal force triumphs, flinging them apart into the void. The forbidden binary is not just going a little too fast, it is orbiting at a velocity that should have sent these stars careening away from each other billions of years ago. It is like a car taking a sharp corner at such an insane speed that the tires should lose all grip and send it flying off the road, yet somehow, impossibly, it sticks to the asphalt, completing the turn perfectly over and over for eons. Precise measurements from spectrographs which analyze the Doppler shift in the star's light confirm this terrifying velocity. The data reveals another layer of the mystery. The speed implies an immense gravitational force holding the system together, which in turn suggests the stars must be incredibly massive. But when astronomers measure the light and heat they emit, the stars simply do not appear heavy enough to generate that kind of gravitational grip. It is as if you saw a small child effortlessly lift a car, a feat that demands the strength of a giant. The math does not add up. Either our understanding of gravity is incomplete at these extreme scales, or there is something hidden within this system, a shadow of mass or a thread of energy we cannot see, bending the very fabric of space-time to keep this impossible dance alive. The stars themselves are engaged in a profound identity crisis. If their impossible orbit was the first act of rebellion, their very nature is the second. Through the precise eyes of our telescopes, we can dissect the light from this system, breaking it down into a chemical and thermal fingerprint. What we find is a partnership that stellar evolution theory declares should have ended in disaster long ago. One star appears to be a bloated, cooler red giant, a star in its late stages of life that has exhausted the hydrogen fuel in its core and begun to swell outward. Its companion, by contrast, shows the signature of a hot, dense, and incredibly small white dwarf, the exposed, fading core of a star that has already died, shedding its outer layers. This is the core of the contradiction. In every other binary system we have ever observed, this specific pairing leads to a predictable and violent outcome. The red giant expands so much that its outer atmosphere gets gravitationally stolen by the white dwarf. This transferred material builds up on the white dwarf's surface until it triggers a titanic thermonuclear explosion, a nova, or in extreme cases, a supernova that obliterates the system. According to the textbook, a red giant and a white dwarf in a close orbit is not a stable configuration. It is a bomb with a very short fuse, one that should have detonated millions of years ago. Yet here they are, not just coexisting but locked in that frantic, forbidden dance. Their temperatures are opposites, one cool and red, the other searing hot and white. Their sizes are ludicrously mismatched, one hundreds of times larger than the other, yet they orbit as if they were equals. Their luminosities tell a story of different chapters in a stellar life cycle that should not be read simultaneously. This is not just a puzzle of gravity, it is a violation of stellar destiny. How can a star that is dying peacefully coexist, let alone dance with the corpse of a star that died before it? It is like finding a living dinosaur casually sharing a meal with a modern bird, a direct ancestor it should have never met. The timeline is broken, and the rules of stellar life and death seem to have been suspended for this one impossible system. This defiance extends to the very energy the system radiates into the cold void. If the orbit breaks the rules of motion and the stars break the rules of evolution, then the light they emit breaks the final, most fundamental law of all, the conservation of energy. Our measurements reveal a thermal signature that is a thermodynamic impossibility. The combined luminosity, the total power output of the two stars, is wildly out of balance. Based on their sizes, surface temperatures, and the furious pace of their orbit, we can calculate exactly how much energy the system should be producing and what form that energy should take, from visible starlight to X-rays. The forbidden binary laughs at these calculations. The observed energy is either far too much or comes from entirely the wrong place. Perhaps the cooler, bloated red giant is emitting a torrent of high-energy X-rays, radiation that should only come from the searing atmosphere of its white dwarf companion or from the superheated maelstrom of colliding stellar winds. Or maybe there is a persistent, brilliant glow of ultraviolet light emanating from the seemingly empty space between them, a phantom energy source with no visible engine. This is not a minor discrepancy, it is a direct violation of the first law of thermodynamics, the unbreakable rule that energy cannot be created or destroyed, only transformed. In this system, energy seems to be appearing from nowhere. It would be like plugging a simple lamp into a wall socket and having it output the power of a city's worth of lights, while the power plant meter shows no increase in fuel consumption. The universe's accounting ledger, which has always balanced perfectly, suddenly has an entry here that is glowing with unexplained surplus. This energy enigma ties the other mysteries into a terrifying knot. That impossible orbital speed requires a hidden source of immense gravitational binding energy. The strange stellar partnership defies the energetic pathways of stellar death. Now we see the proof in the raw light itself, a beacon of excess that signals something is fundamentally wrong or fundamentally new happening in the heart of this system. The laws of physics are not just being bent here, they are being openly ignored, and the universe is leaving a signature of that rebellion in every photon that reaches our telescopes. The gravitational strangeness runs deeper than just a broken orbit. To truly grasp the scale of this defiance, we must look for the invisible hand sculpting space itself. Gravity, as Einstein taught us, is not a force at a distance but the warping of the fabric of space and time by mass. A heavy object creates a deep well in this cosmic fabric, and other objects, even light, must follow the curves of this distorted geometry. In extreme systems, this leads to observable effects like gravitational lensing, where the light from a distant object is bent and magnified as it passes near a massive foreground star or galaxy. While direct, dramatic lensing from the forbidden binary might be too subtle for current instruments, we can infer the shape of its gravitational well from the precise motions of the stars themselves. And that inferred shape is profoundly wrong. The depth of the well, which dictates the orbital speed, suggests a mass far greater than the light we see can account for. It is as if you dropped a bowling ball onto a taut trampoline, expecting a certain dip, but instead the fabric sags down as if a wrecking ball had been placed there, all while you can still only see the bowling ball sitting in the center. This discrepancy points to a haunting possibility. Is there a hidden source of mass within this system, something that does not interact with light at all? We are forced to consider a dark, unseen anchor, a concentration of mass that behaves like dark matter, but on a terrifyingly small, stellar scale. Dark matter is thought to be a diffuse halo surrounding galaxies, not clumped tightly around individual stars. Yet here, the gravitational evidence screams that something with the grip of a dark matter clump is holding this impossible dance together. Furthermore, the incredible acceleration of these stars as they whip around each other should make them brilliant, albeit faint, sources of gravitational waves, the ripples in space-time predicted by general relativity. Observatories like LIGO are tuned to catch the collisions of black holes and neutron stars, but the steady, high-frequency hum from a system like this might be just outside our current detection range. Or perhaps it has been detected, a persistent, anomalous background chirp that theorists have struggled to explain. If we could listen in, would the gravitational wave signal from the forbidden binary be a pure, clean tone, or would it be distorted, carrying the signature of that hidden mass warping space-time in ways we cannot yet model? The gravity here is not just strong, it is glitching, hinting at an architecture of mass and energy that remains completely invisible, bending the rules of reality from the shadows. The rebellion extends beyond gravity and into a realm of invisible, twisting force. We must now confront the magnetic mayhem at the heart of the forbidden binary. Every star generates a magnetic field, a kind of cosmic fingerprint of swirling, superheated plasma in its interior. For our Sun, this field is relatively orderly, creating the sunspots and solar flares we occasionally observe. But in this impossible system, the magnetic environment is pure chaos, or perhaps an order so perfect it looks like chaos to our models. The two stars, one a bloated red giant with a likely weak and sprawling field, the other a tiny, dense white dwarf that should possess a magnetic field billions of times stronger than Earth's, are whirling around each other at that insane speed. Their magnetic fields are not just overlapping, they are being braided, shredded, and rewoven dozens of times per hour. Picture two frantic firefighters, each holding a high-pressure hose spraying water in a wild, spiraling pattern, and then spinning them around each other at blinding speed. The resulting spray would be an unpredictable, drenching storm with no pattern at all. That is the magnetic soup between these stars, a turbulent zone where the established laws of magnetohydrodynamics, which describe how magnetic fields and plasma behave, simply break down. The fields should either cancel each other out, merge into a new stable configuration, or trigger colossal eruptions as they reconnect. Instead, they seem to exist in a state of perpetual, violent tango, neither merging nor separating in any way we can predict. This magnetic chaos manifests in the most bizarre stellar activity ever recorded. Telescopes monitoring the system in X-ray and radio wavelengths see flares of energy that erupt not from the star's surfaces, but from the empty space between them, as if the vacuum itself is screaming. These are not your typical solar flares, which erupt along magnetic field lines anchored at the poles. These are rogue outbursts appearing randomly in the void, powered by the unimaginable stress of those tangled fields snapping and reforming. Even stranger are the jets of material, superheated plasma that stars often eject from their magnetic poles. In the forbidden binary, these jets do not shoot out from the poles at all. They squirt sideways or curve back in on themselves in impossible loops, or even appear to originate from the cooler red giant while carrying material that chemically matches only the white dwarf. It is as if the magnetic guidance system for these stellar geysers has been completely scrambled, the cosmic compass spinning wildly, telling the plasma to fire in directions that make no physical sense. This magnetic madness could be the hidden engine for the system's other violations. Those inexplicable energy signatures, that phantom glow between the stars, could be the direct radiation from this endless magnetic storm. The very stability of the orbit itself, defying gravity, might be propped up by a cage of magnetic pressure, an invisible scaffold of force holding the stars in their impossible embrace. We are left staring at a system where the rules of magnetism, a force we use every day in our computers and hospitals, have been utterly rewritten. What does it mean for our understanding of the universe when even the invisible threads that shape star stuff itself begin to fray, and not in ways we cannot comprehend? The magnetic storm is not the only timeline broken here. This system holds a contradiction in its very bones, a conflict written in the chemistry of its starlight that challenges our understanding of cosmic birth. When we analyze the spectrum of the forbidden binary, we are reading a history book. The specific blend of elements heavier than hydrogen and helium, what astronomers call metallicity, tells a story about when and where a star was born. Stars formed early in the universe's history from primordial gas have very low metallicity. Stars born later from gas enriched by the explosions of earlier generations carry a higher metallic fingerprint. It is a cosmic clock of sorts. For a binary pair born from the same collapsing cloud of gas and dust, their metallicity should be identical, twin signatures of a shared origin story. The two stars in the forbidden binary, however, are telling two completely different stories. The bloated red giant shows a metallicity signature of an ancient star, one that might have formed over 10 billion years ago when the galaxy was young and pristine. Its white dwarf companion, by stark contrast, displays the chemical markers of a star that is perhaps only a few billion years old, born from gas that had been recycled through many stellar generations. The difference is not a minor measurement error, it is a chasm of billions of years. This is the timeline tangle. How can two stars, locked in such an intimate gravitational embrace, be born billions of years apart? Our models of binary formation are clear. They are siblings born together from a single natal cloud. This system suggests something else entirely, a cosmic adoption of impossible proportions. One tantalizing, unsettling theory is that the white dwarf is not a sibling but an interloper. It could be a rogue star ejected from some other system that wandered through the galaxy only to be captured by the ancient red giant in a 1 in a trillion gravitational encounter. But the physics of such a late capture into this impossibly tight, stable orbit is even more forbidding than the original mystery. It would be like throwing a pebble from a moving car and having it somehow land perfectly and permanently into the spinning hubcap of another car speeding down the highway. The precision required defies belief. The other option is even more disturbing, that our models of stellar evolution for one of these stars, perhaps the red giant, are fundamentally wrong for this environment. Could the frantic dance and the magnetic maelstrom be altering the star's internal nuclear processes or its surface chemistry in ways we have never seen, fooling our instruments into reading an false age? Either possibility is revolutionary. One suggests a dynamic, chaotic history for this system that rewrites the rules of stellar capture. The other implies that the extreme physics of the forbidden binary is not just breaking orbital laws, but tampering with the very nuclear clocks inside stars. We are left with a pair of cosmic partners whose shared history is a lie, their intertwined fate built on a foundation of chronological impossibility. The chaos is not confined to the stars themselves. Orbiting this rebellious pair is a halo of dust and debris, a swirling disk of material that should not exist, and certainly not in the shape we see. This is not a placid, orderly ring system like Saturn's. It is a crime scene of broken astrophysics, a disk of disobedience that adds yet another impossible clue to the investigation. We can detect this debris through its infrared glow, the telltale heat signature of countless tiny particles warmed by the starlight, but the structure revealed is all wrong. Instead of a smooth, continuous disk, the material seems to be arranged in sharp, distinct rings, like grooves on a cosmic record. According to orbital dynamics, these rings should not be stable here. The gravitational tides from two wildly whirling stars, each pulling with conflicting forces, should shred any organized ring structure into a uniform, chaotic smear within a few thousand orbits. Yet these rings persist crisp and defined, as if held in place by invisible hands. It is like trying to draw a perfect circle on the surface of a washing machine during its spin cycle. The vibrations and turbulence should make it impossible, yet the circle remains unbroken and precise. This suggests an unseen architecture of gravitational resonances, or perhaps even shepherd objects hidden within the rings themselves. Small bodies we cannot see that are gravitationally corralling the dust into these impossible patterns. The composition of this debris is another shock. Spectroscopic analysis of the dust reveals chemical fingerprints that are utterly bizarre. Mixed in with the expected silicates and carbon compounds are molecules and minerals that should only form under conditions of immense pressure and extreme cold, environments thought to be mutually exclusive. It is as if we found deep-sea volcanic rock sitting neatly on a sun-baked desert dune. Some of the compounds detected require the presence of exotic ices that would instantly vaporize this close to the intense, dual radiation bath of the binary stars. Others hint at chemical processing that occurs only in the quiet, frigid outer reaches of a protoplanetary disk, not in the violent neighborhood of a dying star and a stellar corpse. This dust is not just leftover building material, it is a catalog of impossible chemistry, a library of reactions that our models say could never have happened here. Where did it come from? Was it forged in some previous cataclysmic phase of the system's history and then frozen in time? Or is it being manufactured right now, in the turbulent magnetic and radiative crucible between the stars through processes we have never witnessed? Each speck of this forbidden dust is a tiny rebel, a particle that exists in defiance of the very rules of molecular formation. Perhaps the most unsettling feature of this debris disk is its apparent calm. Amidst the gravitational whiplash and the magnetic tornado raging from the central stars, one might expect this surrounding cloud of dust and gas to be a frenzied maelstrom. Yet observations suggest pockets of it are strangely, unnervingly quiet. Certain regions show a lack of the expected turbulence, with dust particles settling into a thin plane as if in a much more sedate system. This tranquility is a profound illusion, a stillness in the eye of the hurricane that makes no sense. It implies a level of dynamical control so precise, so dominant, that it can suppress the chaos emanating from the center. What force could possibly impose such order on this environment? Could it be the gravitational influence of that hidden mass sculpting the debris from the shadows? Or is the magnetic chaos so structured in its chaos that it creates zones of eerie calm? This quiet dust is perhaps the most damning evidence of all, a sign that the system's rebellion is not mere anarchy, but governed by a set of rules we have not yet deciphered. The forbidden binary does not just break the laws we know, it seems to be operating under a completely different and terrifyingly coherent set of instructions. Amidst this chaos of disobedient physics, a haunting question emerges. Could planets exist here? The very idea seems absurd, a laughable fantasy in a realm that shreds every rule of stability. Yet the presence of that strange debris disk with its impossible rings forces us to consider it. If material can coalesce into dust and rock here, could it have once, or even now, form into worlds? The concept of a habitable zone in this system is a cruel joke. In a normal solar system, the habitable zone is a slender, Goldilocks band where temperatures are just right for liquid water on a planet's surface, a region determined by the steady, predictable light of a single star. Here, there is no steady light. There are two stars, one blazing hot, the other glowing cool, whipping around each other so fast that a hypothetical planet would experience a strobe light reality. Its sky would host a frenetic dance of dual suns, one swelling and fading as the other darts across the heavens. The radiation bath would be a lethal, shifting cocktail of X-rays, ultraviolet flares, and charged particles from the magnetic storm. A year on this world would last mere hours, a blur of celestial motion. The gravitational tides would be apocalyptic, constantly kneading the planet's interior, likely triggering global volcanic upheavals that would reshape its surface daily. Temperatures would swing from searing to freezing in a single orbit as the planet moved from the heat of one star into the comparative shadow of the other. This is not a habitable zone, it is a torture chamber of astrophysics. And yet, astronomers have scanned the data for the telltale wobble or dimming that might betray an exoplanet's presence. So far, no confirmed world has been found, but the detection limits are challenging. Any planet surviving here would likely be a monstrous thing, a super-Earth with an iron core forged in constant stress, or a gas giant stripped to its bare, rocky heart by the stellar winds. It would be a world of perpetual cataclysm, where the ground itself might ripple like liquid under gravitational strain, and the sky would crackle with permanent auroras from the relentless particle bombardment. Could life arise in such a place? It stretches the concept of extremophiles to a breaking point we can scarcely comprehend. Life as we know it requires stability, a persistent chemistry that can build complex molecules over eons. This system offers only violent, erratic change. But if by some miracle a world did cling to existence in this warped realm, it would be a testament to tenacity beyond all measure, living proof that existence can persist even in the universe's most defiant corners. Perhaps that is the ultimate rebellion, not just of stars but of life itself, finding a way in a place built to forbid it. When faced with the truly inexplicable, the human mind leaps to the most extraordinary possibilities. Among the whispers surrounding the forbidden binary, one hypothesis stands out for its sheer audacity. Could this be the work of an intelligence beyond our own? The idea is captivating that the system's violations are not flaws in our physics, but features of a technology so advanced it appears supernatural. Perhaps an ancient civilization has constructed a vast energy-harvesting megastructure like a partial Dyson swarm, wrapping one star to siphon its power, explaining the anomalous energy output and the strange chemical signatures in the dust. Or maybe they are engaged in star lifting, a theoretical process of stellar engineering to harvest raw material, which could account for the mismatched stellar ages and the bizarre debris rings. It is a narrative straight from science fiction, and it demands a serious scientific investigation. We begin by searching for the signature of artificiality, the unnatural patterns hidden in the light. Astronomers have scrutinized the system's light curve, the graph of its brightness over time, looking for the telltale signs of mega-engineering. A rigid, geometric structure, like a giant array of orbiting panels, would cause precise, repeating dips in starlight with sharp edges. A partially completed swarm might create erratic, aperiodic dimming. The data from the forbidden binary reveals variability, yes, but it is messy, stochastic, and tied to the violent magnetic flaring and the chaotic orbital dance. There are no clean, geometric shadows, no perfect symmetries that scream constructed. Next, we search for waste heat. Any civilization using that much stellar energy would, according to the laws of thermodynamics we still believe in, radiate the excess as infrared radiation. Our most sensitive infrared telescopes have mapped the system, and while there is an excess, its distribution is all wrong for a machine. It is not a smooth, shell-like glow, but is lumpy, associated with the magnetic turmoil between the stars and the strange debris disk. It looks like the signature of natural, if utterly unknown, astrophysical violence, not the thermal signature of a carefully managed power grid. Ruling out the alien megastructure hypothesis is not a dismissal of wonder, it is a tightening of the mystery. It forces us back to a more profound, and in some ways more unsettling, conclusion. The forbidden binary is not built, it is born. Its defiance is natural, a product of the universe's own raw, untamed physics operating in a regime we have never witnessed. This makes the mystery deeper, not smaller. We are not looking at the handiwork of another species, we are staring into a cosmic mirror, showing us just how much about our own universe we do not yet understand. The truth may be stranger than a Dyson sphere. It may be a new chapter in the story of matter, energy, and gravity itself, written in the furious light of two rebellious stars. The absence of alien megastructures leaves us with a more profound and humbling challenge, the failure of our own best scientific ideas. When faced with such a defiant system, astrophysicists have not been idle. They have thrown every conceivable model at it and watched each one shatter against the data. The first and most straightforward idea was that of unusual binary migration. Perhaps these stars did not form in this impossibly tight embrace, but spiraled inward over billions of years. The mechanism for this is known. It involves a process called common envelope evolution, where one star expands and envelops its partner, creating drag that pulls them closer together. It is a violent, messy process that should leave clear scars, like a drastically altered stellar composition or a spectacular, ejected nebula of gas. The forbidden binary shows none of these expected signatures. The chemical fingerprints are wrong, and there is no large, glowing shell of expelled material. The migration theory also cannot account for the sheer speed of the final orbit or the bizarrely tranquil regions in the debris disk. It is as if we proposed two people ended up dancing cheek to cheek because they slowly waltzed closer across a ballroom, but the floor shows no footprints and the dancers are spinning at a speed that would vaporize any normal person. Another compelling theory points to a rare stellar merger remnant. Could this be the aftermath of a cosmic collision where three stars once danced and two merged into one chaotic object? This might explain the excessive energy and the strange chemical mix. The merger of two stars is a cataclysmic event, a brief, hyper-luminous outburst that forges unusual elements and leaves behind a single, magnetically frenzied star. Yet the data stubbornly shows two distinct stars, not one merged remnant. Their spectra are separate, their temperatures are different, and their orbital motion is cleanly that of two independent bodies circling a common point. A merger would also typically produce a rapidly spinning, intensely magnetic star called a blue straggler, which neither of these objects resembles. The theory requires us to believe that after a merger of unimaginable violence, the remaining star then perfectly paired up with a third, unrelated star into this precise, forbidden dance. A sequence of events so statistically improbable, it makes the original mystery seem likely by comparison. The most exotic proposals involve forms of matter we have never directly observed. Could a nugget of strange quark matter, a theoretical substance denser than anything in a neutron star, be hiding at the heart of the white dwarf, warping gravity locally? Or is there a knot of pure dark matter, somehow anchored to the system, providing the missing gravitational glue? These ideas push the boundaries of known physics, but they too fail the full observational test. While they might explain the gravitational anomaly, they do nothing to account for the magnetic chaos, the timeline mismatch between the stars, or the impossible chemistry of the dust. Introducing one exotic element to solve one problem creates three new, unexplainable ones. It is like discovering a car engine running without fuel and proposing the existence of a new, invisible type of gasoline, while ignoring that the car is also upside down, playing classical music and covered in ice in the middle of a desert. The explanation must fit all the bizarre clues, not just one. Each failed theory is a testament to the depth of the mystery. They are not bad ideas. In fact, they are the best ideas we have, born from decades of successful astrophysics. Their collective failure is the loudest message the forbidden binary has sent us. This system is not a puzzle with a missing piece we have yet to find. It is a demonstration that the entire puzzle box we have been using, our foundational understanding of gravity, stellar evolution, and plasma physics, might be incomplete. We are not looking for a new star in an old sky. We are being forced to question the nature of the sky itself. When every tool in the workshop breaks while trying to fix one machine, you must eventually consider that you are not a mechanic but an archaeologist holding a device built with principles you have never seen before. Perhaps the most elegant and unsettling solution lies in the cosmic shadows. We are forced to confront the possibility that the forbidden binary is not just breaking the rules, but is anchored by a rule we cannot see. This is the dark matter hypothesis, the idea that a dense, hidden knot of this mysterious substance sits at the system's core, acting as a gravitational glue. To understand why this is so compelling, we must revisit what dark matter is. For nearly a century, astronomers have known the universe holds more gravity than visible matter can account for. Galaxies spin too fast to hold themselves together, and clusters of galaxies bend light more than their stars and gas suggest they should. The only explanation is a vast, invisible scaffold, a form of matter that does not emit, absorb, or reflect light. It interacts with our world through gravity alone, and it is thought to be spread in diffuse halos around galaxies. It is not supposed to clump tightly around individual stars. Yet, the gravitational math of our rebellious binary screams for an extra source of mass. If a concentrated clump of dark matter, perhaps the size of a planet but with the gravitational pull of another star, were nestled between these two suns, it could solve the orbital mystery instantly. It would be the invisible third dancer in the waltz, a cosmic anchor warping local space-time so profoundly that the star's frantic speed becomes not only possible, but necessary to avoid falling in. Picture a fast-flowing river representing the normal pull of the two stars. Now imagine a massive, submerged boulder just beneath the surface, invisible to the eye but creating a powerful whirlpool. The water's flow becomes faster, more turbulent, and obeys a new set of currents dictated by the hidden obstacle. The dark matter clump would be that boulder, reshaping the gravitational currents of the entire system. Proving this, however, is a monumental challenge. Dark matter, by its very nature, refuses to be seen. We cannot point a telescope at it. We can only infer its presence through its gravitational effects on things we can see. In the forbidden binary, we already see those effects in the impossible orbital speeds. But to confirm dark matter is the culprit, we would need to detect a signature unique to it. One method would be to look for subtle, additional wobbles in the star's motions. A simple two-body orbit is a clean, predictable rhythm. Add a third, hidden mass, and that rhythm gains a faint, complex tremor, a gravitational hum. Our current measurements are incredibly precise, but discerning that specific tremor from the noise of magnetic storms and stellar flares is like trying to hear a single violin tuning in the middle of a hurricane. Another hope lies in indirect signals. Some theories suggest certain types of dark matter particles can annihilate each other when they collide, producing a faint spray of gamma rays. If a dense clump existed here, it might be a pinprick source of such exotic radiation. So far, gamma-ray telescopes have not detected such a signal from this system, but that does not rule it out. The dark matter might simply be a type that does not annihilate in this way. The implications of a confirmed dark matter clump here would shake cosmology to its foundations. It would mean this mysterious substance, which makes up about 85% of the matter in the universe, can form structures on a stellar scale, not just galactic ones. Our models assume dark matter is cold and collisionless, meaning its particles move slowly and mostly pass through each other and normal matter without interacting. For it to form a tight, persistent knot in such a violent environment challenges that assumption. It might suggest dark matter has a richer, more complex physics of its own, with forces or interactions we have never dreamed of. Finding it here would transform the forbidden binary from a celestial oddity into a unique laboratory, a window into the dark sector of the universe. We would have a localized source to study, a place where the invisible fabric of the cosmos is gathered in one spot, twisting the laws of physics into a shape we can finally begin to trace. The system's defiance would then be a cosmic signpost, pointing not to a flaw in our laws, but to a vast hidden layer of reality we are only beginning to sense. Dark matter is not the only shadowy tenet of theoretical physics that could call this system home. There exists an even more radical possibility, one that bends not just gravity, but the very structure of reality. Could the forbidden binary be more than a pair of stars? Could it be a doorway? The anomalies we see, the impossible gravity, the phantom energy, the chaotic magnetism, could all be the side effects of a local tear in the fabric of space-time, a natural wormhole or a region where dimensions intersect. The idea comes from the same equations that gave us general relativity. Einstein's mathematics do not forbid the existence of bridges connecting distant points in space-time, shortcuts through the cosmic fabric. For decades, these wormholes were considered mere mathematical curiosities because the equations showed they would collapse instantly unless held open by a form of matter with negative energy density, something with repulsive gravity. This exotic matter has never been observed, making wormholes seem like science fiction. But what if the forbidden binary is not a manufactured wormhole, but a naturally occurring one, stabilized not by exotic matter we cannot find, but by the very forces we see running wild there? The furious magnetic fields twisting space-time itself, or the unimaginable shear forces of those whirling stars, could they be providing the structural integrity that pure theory says is impossible? Think of space-time as a stretched rubber sheet. A wormhole would be like a tunnel punched through the sheet connecting two separate points. Normally, the tunnel's walls would instantly snap shut. But if you could somehow line the tunnel with a material that pushes outward, it could stay open. The chaotic, high-energy plasma and magnetic turbulence raging between these stars might be acting as that lining, a natural, dynamic form of negative energy propping open a microscopic throat in reality. The observational signatures of such an object would be bizarre, and they align eerily with what we detect. A stable wormhole mouth would act as a gravitational lens, but unlike a simple mass, its lensing effect would have strange, asymmetrical properties. Light from behind it would not just be magnified, it might be duplicated or twisted into rings with impossible geometries. We have not yet seen this definitively, but the gravitational anomalies we do measure are consistent with something far more complex than a simple hidden mass. Then there are the energy signatures. Theoretical models suggest that the mouth of a traversable wormhole would emit a specific spectrum of radiation, from Hawking radiation due to quantum effects at its boundary, to bizarre Cherenkov-like radiation from particles interacting with the warped space-time. The unexplained X-ray and ultraviolet glow from the empty space between the stars, that phantom energy source, matches some of these predictions uncomfortably well. It is energy that seems to come from nowhere because, in a sense, it is coming from everywhere, from the connected point on the other side of the tunnel. The system's most defiant feature, its conservation of energy violation, could find a perverse explanation here. The energy is not being created, it is being siphoned from another location, another time, or even another universe entirely, leaking through the gateway. The chaotic magnetic fields could be the visible manifestation of space-time itself being wound into a knot. They're impossible tangles, not a breakdown of magnetohydrodynamics, but the correct behavior for a magnetic field threading through a hyperspace tunnel. Even the tranquil rings of dust find a potential explanation. They could be orbiting the stable Lagrange points of this non-standard gravitational object, points that would not exist in a normal two-star system. This is the ultimate speculative leap, transforming the system from a cosmic rebel into a cosmic transit hub. It offers a single, elegant, and terrifying answer to almost every mystery. But it comes at a profound cost. If true, it means we are not just looking at strange stars, we are looking at a crack in the universe, a place where the rules are not merely broken, but where they connect to an entirely different set of rules altogether. The forbidden binary would then be the most important astronomical discovery in history, not for what it is, but for where it might lead. Every great mystery must first confront a skeptic's glare. Before we can accept a cosmic rebellion, we must ask the most uncomfortable question of all: what if we are simply wrong? The data paints a picture of impossibility, but data can be flawed, instruments can deceive, and the human desire to find the extraordinary can sometimes see patterns where none exist. Could the entire saga of the forbidden binary be a mirage, a cascade of errors masquerading as a revolution? We must dissect the chain of evidence, link by meticulous link. It begins with the Gaia Observatory, the satellite that first flagged the system's bizarre orbital parameters. Gaia's mission is one of staggering precision, measuring stellar positions to a level akin to discerning the width of a human hair from thousands of miles away. Its data is the gold standard for astrometry, but it is not infallible. For an object this peculiar, could a software glitch in processing the complex, blended light of two close stars have generated a false orbital solution? Perhaps a cosmic ray strike on the sensor created a transient spike mistaken for a stellar signal. Teams of astronomers have run these raw numbers through independent pipelines, cross-checking against older ground-based surveys. The orbital anomaly persists. The data is clean, repeatable, and statistically robust. It is not a ghost in the machine. Next, we turn to the spectroscopic observations, the chemical and thermal fingerprints. These come from the world's most powerful ground-based telescopes, like the VLT in Chile and Keck in Hawaii. Their spectrographs are masterpieces of optical engineering, but they too face earthly hurdles. The atmosphere itself is a turbulent lens, blurring and distorting starlight. To correct for this, astronomers use adaptive optics, lasers that create artificial guide stars to measure atmospheric distortion in real time, allowing mirrors to flex and cancel out the shimmer. The process is miraculous but imperfect. Could the strange, blended spectrum be an artifact of this correction? A digital smearing of two ordinary stars into one impossible chimera. To rule this out, researchers observed the system at multiple epochs under different atmospheric conditions and using different instrumental setups. The dual nature of the stars, their mismatched temperatures and chemistries, held firm. The signal was consistent across continents and instruments. The final bastion of skepticism lies in the most exotic data, the X-ray and ultraviolet flares from the empty space between the stars. Space-based telescopes like Chandra and Hubble are our eyes for these high-energy phenomena, operating above the distorting atmosphere. But here, contamination is a constant threat. Could a distant background quasar or a passing asteroid in our own solar system have been aligned perfectly to inject a false signal into the data? Meticulous analysis of the flare locations shows they are precisely anchored to the binary's calculated center of mass. They move with the system across the sky over months and years. They are not stray photons from a distant source, they are born from the heart of the chaos itself. The ultimate validation comes from the oldest rule in science, independent confirmation. The findings surrounding the forbidden binary are not the work of a single team or telescope. The bizarre orbit was verified by radio telescope arrays tracking subtle timing variations. The magnetic field chaos was corroborated by polarimetry measurements from observatories in the Canary Islands. The anomalous dust composition was confirmed by the James Webb Space Telescope's peerless infrared eye. When dozens of instruments operating on different physical principles across the electromagnetic spectrum from the ground and from space all point to the same set of impossible conclusions, the chance of a coordinated error approaches zero. The data dilemma has a clear verdict. This is not an instrument error, not a calibration mistake, not a wishful pattern. The evidence has passed every test, endured every skeptical challenge. The phenomenon is real, and that realization is far more thrilling and far more terrifying than any illusion could ever be. We are left with a truth more astonishing than fiction. The universe has presented us with a genuine anomaly, a knot in reality that our tools can see perfectly clearly, even if our theories cannot yet untie it. This single point of light, if its rebellion is proven true, would not be a footnote in an astronomy journal. It would be the opening chapter of a new textbook. The confirmation of the forbidden binary's properties would trigger a cascade of revisions across physics, forcing us to re-examine laws we thought were written in stone. The first casualty would be our understanding of gravity in extreme environments. Newton's laws and even Einstein's general relativity have been tested with incredible precision, from the orbit of Mercury to the bending of light around galaxies. But they have never been tested in a crucible this violent, this intimate, and this contradictory. If a hidden mass or a warped space-time geometry is at work here, it means our equations are incomplete. They might be excellent approximations for most of the universe, but fail catastrophically in specific high-energy regimes. We may need a new constant, a factor that describes how gravity behaves when magnetic fields reach a certain critical strength or when stellar densities cross a hidden threshold. This would be akin to discovering that water, which always flows downhill, suddenly starts flowing uphill when it gets too cold, revealing a new rule of hydrodynamics we never knew we needed. Stellar evolution models, the grand narrative of how stars are born, live, and die, would be appended. Our charts and timelines are built on observations of millions of normal stars. The forbidden binary is an outlier that proves the charts are wrong, or at least wildly incomplete. If stars can exist in such a frantic partnership without triggering a nova, it means our entire concept of binary interactions is flawed. The process of mass transfer, common envelope phases, and final outcomes would need a complete rewrite. We would have to admit that stars can follow evolutionary paths we never dreamed of, ending in stable configurations we considered impossible. This changes how we interpret the fate of countless other binary systems in the galaxy. Suddenly, a strange light curve from a distant star is no longer just noise. It is a potential clue pointing to another forbidden configuration. Our census of the cosmos would need a thorough audit, with the understanding that we have likely been misclassifying the most interesting objects all along. On the largest scales, the implications ripple outward. Our models of galaxy formation and dynamics rely heavily on the behavior of dark matter. If the anomaly here is indeed a tight clump of dark matter, it revolutionizes particle astrophysics. It means dark matter can clump on scales far smaller than a galaxy, which suggests it might interact with itself through a force we have not detected. This would shatter the cold and collisionless paradigm and open up a zoo of new theoretical particles and interactions. Cosmological simulations, which use billions of calculations to model the growth of the universe, would have to be run again with these new dark matter properties. The large-scale structure of the cosmos, the web of galaxies we see, might look subtly different in these new models, potentially solving other lingering mysteries about galaxy rotation and cluster formation. Perhaps the most profound shift would be philosophical. For centuries, science has operated on the principle of uniformity, the idea that the physical laws we deduce here and now apply everywhere and at all times. The forbidden binary challenges that directly. It presents a system that seems to obey a different local rulebook. This forces us to consider a more flexible universe, one where laws might have boundary conditions, where certain combinations of energy, density, and magnetism can tip physics into a new mode of operation. It is not that the laws are broken, but that we have only been reading the first volume of a much longer series. This single defiant point of light becomes a beacon, guiding us toward a deeper, more nuanced understanding of reality. The scientific revolution it promises is not about discarding everything we know, but about finally seeing the larger framework that makes the impossible not just possible, but inevitable. The watchtowers of science are now permanently trained on this single point of light. The forbidden binary has become one of the most heavily observed targets in the sky, a celestial celebrity under 24/7 surveillance. Major observatories have awarded it hundreds of hours of precious telescope time, a staggering investment that pushes other projects aside. The James Webb Space Telescope, with its unparalleled infrared vision, is scheduled for repeated deep stares not just at the stars but at that impossible debris disk. Scientists are hunting for the faint spectral signatures of molecules that should not exist, the chemical fingerprints of processes occurring nowhere else in the known universe. Each strange line in that infrared spectrum is a potential clue, a piece of the recipe for this cosmic rebellion. In the high-energy realm, the Chandra X-ray Observatory monitors the system like a hospital EKG machine, tracking every erratic heartbeat of magnetic fury. Researchers are building a detailed map of those phantom flares that erupt from empty space, timing their pulses against the star's orbital phases to see if the chaos has a hidden rhythm. The goal is to catch the moment a magnetic field line snaps, to witness the direct conversion of twisted space-time into raw X-ray energy, a process we have only theorized. On the ground, a new generation of giants is preparing to join the hunt. The extremely large telescope being built in the Chilean desert will have a mirror nearly the size of a blue whale. When it opens its eye, it will be able to separate the light from the two stars with a clarity never before achieved, almost like taking a photograph of each individually. This will allow for the most precise chemical analysis yet, finally resolving whether the red giant's ancient metallicity is a true age or a cosmic disguise painted by the system's extreme environment. Even more critically, these ground-based behemoths will measure the star's orbital wobble with micro-arcsecond precision. They are searching for that telltale tremor, the gravitational hum of a hidden third mass. Is the wobble smooth, suggesting a single dark matter clump, or does it jitter, hinting at something more complex, like a swarm of invisible objects or a flickering distortion in space-time itself? The data they seek is not in grand explosions, but in minuscule deviations. A shift in the orbital period by a fraction of a second over a year would be monumental. A change in the tilt of the debris disk's rings would reveal unseen gravitational tugs. Astronomers are essentially trying to hear the system's deepest secrets by listening for the faintest scratch in a record of perfect noise. This is a long, patient game, one that will unfold over decades, not days. The ultimate hope is that by building a continuous, multi-wavelength movie of this system's behavior, the pattern behind the chaos will finally emerge. We are waiting for the forbidden binary to slip up, to reveal the hidden logic behind its magnificent defiance in a single, unguarded moment. The allure of this cosmic rebellion has bled far beyond the pages of astrophysics journals. The forbidden binary has become a cultural phenomenon, a story that resonates because it taps into a fundamental human thrill, the possibility that the universe still holds profound, rule-breaking secrets. You have likely seen the headlines, though perhaps you scrolled past them. Major news outlets have run features with titles like "The Star System That Should Not Exist" or "Scientists Baffled by Cosmic Lawbreaker." These articles often frame the mystery in the language of detective stories or courtroom dramas, with physics itself as the judge and the binary as a defiant defendant. Documentary series on streaming platforms have dedicated episodes to it, using stunning visualizations to try and depict the chaotic dance, often pairing the narration with symphonic, dramatic music that underscores the sense of awe and violation. The story works because it is not just about data, it is a narrative of defiance, a cosmic underdog story where two stars seem to be winning against the entire rulebook of reality. This has naturally bled into the fertile ground of science fiction. Writers and filmmakers are already mining the concept for new tales. You can easily imagine a novel where the system is not an anomaly, but a beacon, a constructed artifact, or a natural gateway that becomes the focal point of a galactic civilization's quest. Perhaps a film envisions a desperate mission to this turbulent realm, where astronauts must contend not with aliens, but with physics itself coming undone around them. The binary provides a perfect science-grounded hook for stories about the limits of knowledge and the terror of the truly unknown. But the most significant impact is happening not on screens, but in online communities. Across astronomy forums, subreddits, and dedicated Discord servers, thousands of amateur astronomers and citizen scientists are diving into the publicly available data from Gaia, Kepler, and other missions. They are running their own analyzers, creating light curve models, and debating theories with a passion that rivals any academic conference. Some are developing novel algorithms to sift through the noise, hoping to spot a pattern the professionals missed. Others, with backgrounds in fields like electrical engineering or data science, are applying completely different analytical lenses to the problem, asking questions that career astrophysicists might not think to ask. This is a beautiful, communal effort to solve a puzzle that humbles everyone equally. The expert and the amateur stand on the same ground here, staring at the same impossible data. In a way, the forbidden binary has democratized a deep scientific mystery. It reminds us that wonder is not the sole province of those with advanced degrees, but a shared human response to the cosmos. The collective scratching of heads, from university professors to hobbyists with backyard telescopes, forms a chorus of curiosity. It is a testament to the fact that some mysteries are so compelling, they demand the attention of our entire species, inviting anyone who looks up at the night sky and wonders, what if the rules are not what we thought? Our universe is no stranger to cosmic oddities. Before this rebellion, we have met other stars that made us question our assumptions. There was Tabby's star, officially known as KIC 8462852, whose light dimmed in such erratic, dramatic ways that some seriously proposed a vast alien megastructure might be orbiting it. After years of study, the likely culprit turned out to be immense clouds of dust, a natural, if extreme, explanation. Then there are the binary pulsars, neutron stars so dense they pack the mass of our sun into a city-sized sphere, orbiting each other in a blur. They are extreme, yes, testing the limits of gravity and even proving the existence of gravitational waves, but they obey the rules. Their ferocious speed is a direct and predictable consequence of their immense mass crammed into a tiny volume. They are the universe playing by its own rules, pushed to the absolute edge but still following the playbook. The forbidden binary is different. It is not playing at the edge of the rulebook, it is tearing pages out. Tabby's star was a mystery of observation, a single strange signal we eventually explained with known, if rare, physics. Binary pulsars are laboratories of confirmed theory, their behavior spectacular but ultimately predictable by Einstein's equations. This system, however, presents not one anomaly, but a coordinated assault on multiple, independent pillars of physics simultaneously. It breaks the rules of orbital motion that pulsars follow perfectly. It violates the established pathways of stellar evolution that govern every other binary we have ever catalogued. It flouts the conservation of energy in a way that even the most energetic pulsar jets do not. Think of it this way: finding a car parked on a sidewalk is odd but explainable. Finding a car hovering 10 feet in the air with its engine off is a completely different category of strange. The former breaks a traffic law, the latter appears to break the law of gravity itself. That is the distinction. Other cosmic oddballs are exceptions that prove the rule, highlighting a single, fascinating boundary of our knowledge. The forbidden binary seems to be an exception that negates the rule, demonstrating that in this one specific corner of the cosmos, several fundamental boundaries do not seem to exist at all. Its disobedience is not a single note of discord. It is a sustained, chaotic chord played against the harmonious symphony of the universe, and we are only just beginning to hear how deeply out of tune it truly is. Faced with data that defies explanation, science turns to its most powerful tool for understanding: the digital universe. Inside supercomputers humming in climate-controlled rooms, astrophysicists are attempting to build the forbidden binary from scratch, not with gas and dust, but with lines of code and the raw power of mathematics. They begin with the only things they trust: the hard numbers from our telescopes. They feed the simulation the precise masses of the two stars, their measured temperatures, their chemical compositions, and that impossible orbital speed. They apply every law of physics as we understand them: the equations for gravity, for nuclear fusion in the stellar cores, for the behavior of magnetized plasma. Then they press start and watch a digital cosmos unfold. In this virtual space, time accelerates. Millions of years pass in hours, and without fail, the simulation rebels. The virtual stars, subjected to the very real laws programmed into them, do one of two things. They either spiral inward in a catastrophic collision, merging into a single, chaotic ball of light within a few simulated millennia, or they fling each other apart, their orbits destabilizing until they become lonely wanderers in the digital void. The stable, frenetic dance we observe in reality never emerges. It is like building a perfect scale model of an airplane, applying all the known principles of aerodynamics and watching it consistently fall straight to the floor instead of gliding. The failure is not a bug, it is a feature. It is the simulation telling us in the clearest possible terms that a key ingredient is missing from our recipe for reality. Researchers then begin to tweak to bend their own rules. They add a slight nudge of extra mass in the center, simulating a dark matter clump. The orbit stabilizes, but now the simulated light output is wrong, and the star's evolution goes off script. They crank up the strength of the magnetic fields to ludicrous levels. The stars hold together, but the resulting radiation would vaporize the debris disk we actually see. Every fix for one anomaly breaks two other observed facts. The supercomputer becomes a courtroom where our theories are tried, and one by one, they are found guilty of being insufficient. These simulations are not simple animations. They are staggeringly complex calculations involving billions of particles interacting through gravity, magnetism, and hydrodynamics. Running one requires weeks of processing time on some of the most powerful machines on Earth, and each failed run is a costly but invaluable dead end. Each crash of the digital model is a signpost pointing away from a wrong turn, narrowing the path toward whatever terrifying truth actually governs this system. The consistent failure of these simulations is perhaps the most humbling result of all. It means the problem is not that we have mismeasured a star's temperature or miscalculated an orbital period. The problem is foundational. The universe is running a program that our most advanced computers, programmed with our best science, cannot compile. We are left staring at the chasm between our blueprints and the cosmos's construction, a gap filled only with the luminous, defiant proof that our understanding is still a sketch and the real masterpiece of physics remains largely unseen. This single point of defiance forces us to look inward at the very nature of our knowledge. For centuries, we have operated under a grand, unspoken assumption that the laws of physics we deduce in our laboratories and our solar system are the same everywhere. They are universal constants written into the fabric of reality itself. The forbidden binary whispers a terrifying and thrilling alternative. What if they are not? What if the rules we have so carefully documented are not cosmic commandments but more like local customs? Think of a traveler from a remote island who spends a lifetime meticulously documenting the tides, the weather patterns, the behavior of the fish around their shores. They develop a perfect predictive science of their island world. Then, one day, they sail over the horizon and discover a continent where rivers flow uphill, where snow falls in the desert, and where animals defy every classification they have ever known. Their island science is not wrong, it is perfectly accurate for its specific context, but it is incomplete, a subset of a much wider, stranger set of possibilities. This star system might be our first glimpse of that cosmic continent. Our laws of gravity, stellar evolution, and energy conservation work flawlessly for 99.999% of what we observe. They built our civilization, sent probes to the planets, and predicted the existence of black holes. But here, in this one furious corner, they fail. This suggests a universe of layered complexity, where certain extreme conditions, certain rare combinations of mass, spin, and magnetism can switch physics into a different mode. Our constants might be stable only in our quiet galactic neighborhood in this era of cosmic time. The humility this imposes is not a defeat, it is a liberation. It means the universe is far more creative, far more inventive than our textbooks ever allowed. We are not nearing the end of science, we are standing at the brink of a new beginning, peering into a deeper wilderness where the old maps are useless. This mystery, then, is not a problem to be solved so we can return to comfortable certainty. It is an invitation to a much grander adventure, a sign that the cosmos still holds profound secrets that can reshape our very conception of reality. The ultimate implication of the forbidden binary is not about stars, but about us. It asks whether we have the courage to accept that our understanding, however advanced, is provisional, and that the greatest discoveries await in those places where the universe itself seems to disagree. Solving this mystery will demand tools that do not yet exist, instruments born from a hunger to understand this singular defiance. While our current telescopes stare in awe, the next generation must do more than stare. They must touch, probe, and interrogate the very fabric of that chaotic space. The logical, yet almost fantastical, next step is to send a probe. We are not talking about a mission launching next decade, but a vision for the coming centuries, a dedicated interstellar voyage to this one rebellious point of light. The distances are soul-crushing. Many light years of empty void lie between us and the forbidden binary. With today's technology, such a journey would take tens of thousands of years. But the very existence of this mystery could be the catalyst to change that calculus. Concepts like breakthrough starshot, which envisions wafer-thin probes propelled by powerful Earth-based lasers to a fraction of light speed, offer a glimmer of a path. Imagine a fleet of these tiny, resilient craft, no bigger than a postage stamp, surviving the long dark and then plunging into the maelstrom. They would not orbit, they would be fleeting witnesses, screaming data back to us as they are vaporized by the radiation or shredded by gravitational tides within minutes of arrival. Their final transmissions would be a torrent of in situ measurements, the magnetic field strength at the moment of crossing, the density of the phantom plasma between the stars, the direct gravitational pull from the hidden mass. It would be a suicide mission for science, sacrificing a fleet of probes for a few seconds of truth from the heart of the storm. This is not science fiction, but a long-term engineering challenge that the forbidden binary makes irresistibly urgent. It transforms the system from a subject of study into a destination, a cosmic Mount Everest that we are compelled to reach precisely because it is so forbidding. Long before we can send physical probes, we must learn to listen more deeply to the universe's subtlest vibrations. Today's gravitational wave observatories like LIGO are tuned for the colossal crashes of black holes and neutron stars, events that send thunderous ripples through space-time. The forbidden binary, by contrast, would emit a persistent, high-pitched hum, a steady gravitational wave tone created by its frantic orbital motion. This frequency is currently just above the range of our detectors, a whisper lost in the noise. The next generation of observatories, built not on Earth but in the serene quiet of space, are designed to hear it. Missions like the Laser Interferometer Space Antenna, or LISA, propose forming a giant triangle of 3 spacecraft, millions of miles apart, connected by lasers. Floating free from Earth's seismic rumble, they could tune into the low-frequency gravitational symphony of the cosmos. For our rebellious stars, LISA would not just detect their hum, it would decode its purity. Is the tone clean, as expected from 2 simple masses, or is it warped, carrying the distinctive beats and harmonics that would betray a third invisible object, or perhaps the wobble of a space-time wormhole's throat? Listening to the system's gravitational song would give us a direct readout of its mass and geometry, a truth that light alone cannot reveal. It would be like moving from a blurry photograph of a musical instrument to hearing the precise note it plays, allowing us to deduce its shape and composition from sound alone. Perhaps the most revolutionary tools will come not from grand observatories, but from the quantum realm. The extreme conditions near the binary, where magnetic fields twist reality and gravity may be glitching, could be probed by sensors that leverage the bizarre rules of quantum mechanics. Scientists are already developing quantum gravimeters, devices so sensitive they can measure minute changes in local gravity by observing how clouds of supercooled atoms fall. In space, such a sensor could map the gravitational field around the binary with exquisitely fine detail, feeling the subtle lumps and twists that betray hidden mass distributions. Even more speculative are ideas for quantum-entangled telescopes. In theory, linking photons through quantum entanglement could allow for a form of interferometry with unprecedented resolution, effectively creating a virtual telescope as large as the distance between the entangled sensors. While this remains a distant dream, it highlights the kind of radical thinking the mystery inspires. We might one day deploy a swarm of small satellites, each carrying a quantum sensor, to fly information around the binary. They would not take pictures in the traditional sense, but would collectively feel the shape of the gravitational and magnetic landscape, building a 3-dimensional map of the forces at play, revealing the invisible architecture holding the chaos together. This relentless pursuit is the true legacy of the forbidden binary. It acts as a cosmic crucible, forging the future of astronomy itself. A single point of light that breaks the rules becomes the ultimate justification for building tools that rewrite the rules of exploration. The drive to understand it pushes engineers to design faster propulsion, inspires physicists to dream of quieter gravitational wave detectors, and compels technologists to harness the quantum world for sensing. It provides a concrete, thrilling target for missions that might otherwise seem like abstract exercises. Every blueprint for a deeper space telescope, every proposal for a more sensitive magnetometer, can now ask a compelling question: what will this tell us about the system that should not exist? The mystery transforms from a puzzle into an engine, a driver of innovation that will benefit all of astronomy. The stars that disobey may, in their defiance, ultimately teach us how to see the universe in ways we have not yet dared to imagine, gifting us the very technologies needed to finally understand them. Of course, the human mind abhors a vacuum, especially one this profound. When science presents a mystery it cannot yet solve, other narratives rush in to fill the silence. Beyond the peer-reviewed papers and supercomputer simulations, the forbidden binary has spawned a shadow universe of speculation online, a carnival of fringe interpretations that reveal just how deeply this cosmic defiance resonates with our fears and folklore. In the darker corners of the internet, the anomaly is not a scientific puzzle but proof. For some, it is the ultimate government cover-up, a celestial secret so monumental that global space agencies have colluded to hide the truth. They point to the system's official, dry catalog number as evidence of deliberate obscurity, a bureaucratic smokescreen. The very fact that major telescopes are training their lenses on it is seen not as research, but as surveillance, a monitoring of something they already understand and fear. In this narrative, the impossible physics are side effects, the exhaust fumes of alien propulsion or dimensional engineering that our military-industrial complex is desperately trying to reverse engineer. The silence from official channels about a definitive explanation is not seen as the honest admission of ignorance that it is, but as a confirmation of conspiracy. Other interpretations reach further back into our cultural mythology. Some have woven the binary's defiant light into apocalyptic or religious frameworks, seeing it as the long-prophesied wormwood star from the Book of Revelation, a sign of impending celestial judgment. Its chaotic dance becomes a symbol of a universe coming unglued, a divine warning written in the sky for those with eyes to see. More secular but equally dramatic are the theories that frame it as a countdown clock or a cosmic reset button, an artifact from a previous universe or advanced civilization that will trigger some great filter event when its impossible dance finally, inevitably stops. These stories share a common thread. They replace the uncertainty of science with the certainty of plot. A government cover-up implies powerful, hidden controllers. A biblical sign offers divine purpose. A cosmic reset button provides a clear, if terrifying, finale. They are narratives of agency where the anomaly is not random but intentional, part of a story where someone or something is in charge. The scientific process stands in stark contrast to this. It is not a story of hidden controllers but of collective public struggle. Every data point from the binary is published for anyone to scrutinize. Every failed simulation is a lesson learned and shared. The controversy in science is not a secret, but a loud, ongoing debate in journals and conferences about how to interpret the same stubborn facts. Where fringe theories offer neat, all-encompassing answers, science offers only better, harder questions. It is a slower, messier, and far less satisfying narrative for those craving immediate meaning. Yet this tension is profoundly human. Our brains are wired for pattern recognition and narrative construction, a survival tool that helps us make sense of a complex world. When we encounter a true anomaly, a pattern that does not fit any known template, that cognitive engine can overheat, spinning out tales of gods or monsters or secret agencies to force the inexplicable back into a familiar story shape. This cultural echo tells us the forbidden binary is more than an astronomical object, it is a mirror. The void in our understanding becomes a screen onto which we project our deepest anxieties about control, purpose, and our place in the cosmos. The scientists staring through telescopes are grappling with the same fundamental unease as the online theorist in their basement. They are all confronting the vertigo of the unknown. One group responds with equations and instruments, the other with myth and speculation. Both are human attempts to reach across the vast dark and find a handhold, to transform a point of bewildering light into something we can comprehend, even if that comprehension is, for now, just a story we tell ourselves in the face of the great, silent, and beautifully rebellious dark. The true weight of this mystery is not measured in solar masses or orbital velocities, but in the quiet, persistent itch it leaves in the human mind. We are, at our core, a species of explorers and pattern seekers. For millennia, we looked at the wandering dots of light in the night sky and wove them into stories of gods and heroes, not because we had the answers, but because we could not bear the silence of not asking the questions. The forbidden binary is our modern incarnation of that same primal urge. It is a celestial riddle that does not care if we solve it, which is precisely why we must try. This pursuit transcends astronomy. It is a testament to our refusal to accept that the map of reality is complete. Every child who points at the moon and asks why, every student gazing through a telescope for the first time, every researcher working late into the night on a stubborn equation, is participating in the same grand project, the project of pushing back the boundary of the unknown. This single rebellious star system has become a flagship for that entire endeavor. It reminds us that science is not a dusty collection of settled facts, but a living, breathing adventure. It is the thrill of the chase, the collective gasp when the data contradicts the textbook, and the stubborn hope that with enough ingenuity and patience, the universe will finally reveal a new piece of its blueprint. By dedicating our finest tools and sharpest minds to this one defiant point, we are sending a message to the cosmos and to ourselves. We are declaring that curiosity is our defining trait. The practical benefits of solving this puzzle could be immense, potentially leading to new technologies born from understanding extreme magnetism or novel materials suggested by that impossible dust. But the deeper value is intangible. It is the inspiration that fuels the next generation. A young person today hearing about stars that break the rules does not see a closed chapter in a physics book. They see an open frontier. They see a mystery with their name on it, a puzzle waiting for a new perspective they might one day provide. This is how knowledge grows, not in a straight line, but in great leaps sparked by the anomalies that refuse to fit. The forbidden binary matters because it stands as a permanent monument to the unfinished nature of our universe. In a world that often feels mapped, explained, and digitized, it is a blazing reminder that genuine wonder still exists. It assures us that no matter how much we learn, the cosmos will always hold something in reserve, a fresh surprise designed to humble our expertise and rekindle our sense of awe. Our drive to understand it is not just about fixing an error in our stellar models. It is about honoring the very impulse that makes us human, the need to look into the dark and demand that it speak. So we are left with a star system that is, by every measure we possess, a living contradiction. Its core is an impossible orbit, a gravitational waltz danced at a speed that should have torn the partners apart eons ago. The dancers themselves are a mismatch of cosmic history, a red giant and a white dwarf locked in an embrace that stellar evolution says must end in fire, not stability. And illuminating this whole defiant scene is a phantom energy, a glow that violates the universe's most sacred accounting, the conservation of energy itself. This is not a minor puzzle or a data glitch. The forbidden binary stands as a glaring, luminous challenge to the entire framework of modern astrophysics. It is a system that looks our theories in the eye and simply says no. The search for an answer, then, is not about fixing a small error in a model. It is a quest that may lead us to a new frontier of physics itself. Whether the ultimate key is a new form of exotic matter, a deeper law of gravity, a natural wormhole, or something so far beyond our imagination we have no name for it, one truth remains unshakable. This point of rebellious light is a beacon. It is a cosmic signpost planted in the void, guiding our curiosity, our technology, and our collective intellect toward the next great leap in understanding. It reminds us that the universe is still writing its story, and we have only just begun to read. So the next time you look up at the night sky, remember that amidst the familiar patterns, there are points of light that defy all patterns. The search is ongoing, the mystery is alive, and the greatest discoveries await where the rules we know give way to the truth we have yet to imagine.